Okay then, let's have a go at this one. We got y equals x to the 5 minus 4x. So let's differentiate that then. To y dx, find the turning points, if any. 5x to the 4, yeah? Minus 4, agreed? Let that equal 0. So 5x to the 4 equals 4 then. So x to the 4 is equal to 4/5. Take the fourth roots because the property x to the a to the b, if you remember, is x to the a times b. That's the property of indices there. So if that's a 4, then to undo a fourth power, you take the quarter, because 4 power you times, and 4 times a quarter is 1. So to get that to be 1, if I take power quarter of this, then that will then reduce 4 times quarter is 1. That will reduce to 1. So power quarter on the left would be the power quarter, which you can write as 4/5 to the quarter if you want. Or you can write it, the power quarter, you can write it, if I get it right, write it like that. Or you can write that as the fourth root. It's the same thing, just notation. Alright. So it's a fourth root of 4/5. So you're going to get plus and minus, aren't you? So I'll put the plus and minus here straight away. Because when you take the fourth power, the minus times a minus 4 times will become a plus, and that's what you want. So tap that in the calculator then. We've got 0.8 power quarter. So 0.8, which is 4/5 power, quarter, which is 0.25. That's the quickest way to do it. Yeah? 4/5 power quarter. 0.945, so that'd be 0.95, won't it? Yeah? So x equals plus or minus 0.95. So that's what, now we need to work out x equals 0.95 then. What does the output give? So it'd be 0.95 to the power 5 minus 4 times 0.95 to the power 1, because it's just 4 lots of x, yeah? So let's tap that in the calculator then. We've got a bracket. I'll put a bracket around it, so I'm going to change it in a minute. 0.95 bracket power 5 ground level minus 4 times bracket 0.95 bracket, that's it, equals minus 3.03, because that's a 6, minus 3.03. There we go, there's the output. And then add x equals minus 0.95 then. Let's put that in. Now, because I've got it back in the calculator, what I can do now is I can just toggle back, and instead of 0.95, we can flip a minus in there, can't we, there? Because it only occurs there. And there's one other place which is just here. Put a minus in there. That's it. And then just press equals. 3.03, yeah? So 3.03. Okay. Alright, that's the y value there. Good. So there's your input outputs. Now we don't know whether they're max or mins. We're running out of room here, so let's just do that on the next page, shall we? So we got y equals x to the 5 minus 4x. And now we're going to draw our graph. There's 0, here's the x-axis, here's the y. Now we want to put in the 0.95, wasn't it, was the first one? If you remember, and minus 0.95 was the inputs. The outputs were for 0.95, it was minus 3.03. Okay, so it was minus 3.03, yeah, was the output. And for minus 0.95, if you look back, it was plus 3.03. Okay, so that would be plus 3. I just put it over here because there's not much room there. So we don't know whether it's a min or max yet, do we, or whatever. So let's just draw it like that. There's the possibilities. So now we do the second derivative then, d2y by dx squared. So remember what dy dx was? I just put it here for reference sake. It's easy to write down anyway. So get d2y by dx squared then, it will be 20x cubed. And the 4 goes to nothing. So when x equals minus 0.95 and when x equals 0.95, what do we get? Well, first of all, 0.95, that's positive. Positive cubed is positive. 20 times a positive is a positive, so that's positive. So it's a min. And here, if we've got a negative number, negative cubed is negative, because it's minus times a minus times a minus. And a negative times positive is a negative, so this will be negative, won't it? So that's a max. So it looks like we've got a max at minus 0.95. So it was a max at that. And it looks like we got a min at 0.95. That's what we got. Oh. Bit strange, isn't it? Let's go back here. 5x to the 4 minus 4. X to the 4 is that. Take the 4 through. Quarter. 4 through. Yeah? Take the 4th root of that, you get that. That looks okay to me. Input 0.95. You're going to get a negative. Input minus 0.95. You're going to get a positive. That seems fine. So go back here. That was a positive. That was a negative. d2y was, this is fine. 20x cubed, this is fine. Right, max 20x cubed when it's negative. That's a negative, it's negative, so it's a max at minus. I've drawn them around the wrong way, haven't I? That's all. So sorry about that. That's a max. So let's just get that in. So on the minus 0.5, it was a max. Yeah, and this one was a min. Great! So there we are then. It comes down. It swings around here as a minimum. It comes back up there as a maximum. And it goes back like that. And that's y equals x to the 5 minus 4x. There we go. That's the curve there, yeah? It does go through 0 actually. So it's a very easy point to get. So you can also draw that line going through 0. Because if you put 0 in here, it's easy to see that when x is 0, y is 0. So it would have been nice to have sketched that actually, it going through 0. So let's have a look at the plot then on our thing, on our calculator, on our graphical thing that we found in Google, because there's tons of them, I think. You can just find one of them. X to the 5, x power 5, minus, and we're going to do 4 times x, aren't we? Let's return that. See what we get. X to the 5 minus 4x. There we go. And we'll do from minus 2 to 2, won't we? Yeah? Because this will be a better graph. Minus 2 to 2. Okay, let's have a look at that. There we are. That's not exactly what we... Well, it is more or less actually. See it going through 0? As we said, the minimum here, 0.95 minus 3.03, and then minus 0.95, and 3.03 positive. Yeah. Great, good. That's good. So that's 1610 then? Great, let's go on to the next one.